Welcome to Get Your FRQ On. This question is from 2018. It's question 4, and it is not calculator active. In the question stem, we have the height of a tree at time t, given by a function h, which is twice differentiable. H measures the height of the tree in meters, t is measured in years, and we have a table of selected values for h of t. In part A of this question, we are asked to estimate the value of h prime of t at t equals 6, provide the correct units, and interpret its meaning. H prime of 6 can be found using the formula for average rate of change. Using the values from the table, h of 7 minus h of 5 over 7 minus 5 is 11 minus 6 all over 2, which reduces to 5 over 2, so we have 5 over 2 meters per year. So h prime of 6 equals 2.5 meters per year, means that the height of the tree is increasing at a rate of 2.5 meters per year when t equals 6 years. In part B of this question, we are asked why there must be at least one time t on the interval from 2 to 10, such that h prime of t is equal to 2. So what we want to do is we want to find some interval in the table, which is a subinterval of 2 to 10, where the average rate of change is 2, and we note from the table that the average rate of change between t equals 3 and t equals 5 is equal to the following. We have h of 5 minus h of 3 all over 5 minus 3, which is 6 minus 2 over 2, which is 4 over 2, which is equal to 2. So we have a subinterval of 210, where the average rate of change is 2. We're given in the question stem that h of t is twice differentiable, so there must be a value of c between 3 and 5 such that h prime of c is equal to 2. Therefore, there must also be at least one time t on the interval from 2 to 10 where h prime of t is equal to 2, since one such value of t is already guaranteed in the interval from 3 to 5. In part C of this question, we are asked to find the average height of the tree on the interval from 2 to 10 using a trapezoidal sum and the 4 subintervals indicated by the table. The average height of the tree can be found by evaluating the definite integral 1 over 10 minus 2 times the integral from 2 to 10 of h of t dt. You'll note that this is the formula for the average value of a function. So we get 1/8 the integral from 2 to 10 of h of t dt, which is 1/8 of 1 times 1.5 plus 2 over 2 plus 2 times 6 plus 2 over 2 plus 2 times 11 plus 6 over 2 plus 3 times 15 plus 11 over 2. Notice that each of these is the formula for the area of a specific trapezoid. Your work will kind of need to show that. This will simplify to 1/8 of 7/4 plus 8 plus 17 plus 39, which is 1/8 of 65 and 3/4, which is 263 over 32. From this, we can conclude that the average height of the tree over the interval from 2 to 10 is 263 over 32 meters. In part D of this question, we are given a function g of x equals 100x over 1 plus x, and x here represents the diameter of the tree, and when the tree is 50 meters tall, the diameter is increasing at 0.03 meters per year. we are asked to find dg dt at this time. So g of x equals 100x over 1 plus x equals 50, which is the height of the tree. If we solve this equation, we can determine the value of x for which this is true. So if you solve this, you get a value of x equals 1. So whenever the tree is 50 meters tall, its diameter is 1 meter. dg dt, by definition, and the chain rule is dg dx times dx dt. We can find dg dt by finding the derivative of g using the quotient rule and then multiplying by dx dt. Dg dx is 100 times 1 plus x minus 100x all over 1 plus x quantity squared. And then I just need to multiply that by dx dt. So dg dt, specifically when x is equal to 1, is going to be 100 over 1 plus 1 squared times dx dt, but we know that dx dt is 0.03 here, and we get 0.75. So when the tree is 50 meters tall, its height is increasing at 0.75 meters per year. If you want more AP Calculus AB free response question solutions, don't forget to like this video, subscribe to my channel, and you can even follow me on X at x.com/getyourfrqon.